Okay, so next we're going to move on to the next part of the report. So previously, we added the definition of a box plot to the definitions section. So here under definitions, right here on box plot, okay, this is where we added the box plot definition, put in an illustration that we created to give a general picture of what a box plot is and the different parts. And then kind of defined what each of those parts are. Again, I'm using filler text. Okay, your text should not be filler. Your text should explain what each of these different items are. And box plots can be skewed left or skewed right. So here are examples of box plots. This one is left skewed, and this one is right skewed. So we've added the definition of a box plot, and the reason why we did that is because we want to include box plots of our data in the results. So here in the results, we already have a data table. Okay, this is what you added before. All we need is a couple of rows to kind of show the data table. And previously, you added histograms. And so below the histograms, in this space down here is where we're going to put our box plots of our data. Already you'll kind of notice these symbols here in blue. Okay, these are formatting symbols. And just if you don't have that shown, click under View and click on Show Not Printing Characters. Okay, you'll notice as I turn that off, they go away. Turn that back on. So non-printing character, this means a carriage return. And then we've got page breaks in here. So it kind of makes some of the invisible things that the word processor is doing, it makes it visible so you can see what's going on. Okay, so now what we want to do is we want to add box plots in results here. So under this section, or this subsection that we're calling distribution, shape of height and speed of roller coasters, this is where I'm going to start typing about box plots. So I think I'll just start here on this page. And so I'll say maybe something like box plots of speed, miles per hour, and height are shown in figure M and N respectively. All right, so I just put a sentence saying that I've got two box plots, one of speed and one of height. So to insert pictures and some figures and their captions, I'm going to insert a table that is 2 columns wide and 2 rows high. And down here, this is going to be figure M, which is a box plot of speed. And over here is going to be figure N, which is going to be a box plot of that. Okay, so now we need to add in the 2 box plots here. So, these box plots are what I made in Google Sheets. So I made one of speed and I made one of height, and I downloaded them as PNG image files. And so that's what I'm going to be importing in. So I'm going to go to Insert, Image, Upload from Computer. And this is the directory where I saved them to. And I don't want height, I want speed. So I'm going to double click that. Okay, and it inserted it. Now I'm going to click here in this cell and I'm going to import the height box plot. So insert, image, upload from computer, and here is height. All right. So I decided to put these box plots on two separate axes, okay, to have their own axes here, because one is in miles per hour and the other one was in feet. And that was one reason. The second reason is that the data for speed went from 0 to about 160, which if I had done it on this scale, 0 to 160 is here. So this one would have been like really short and squat here alongside this one, which would have been much taller. So it just wouldn't have made a really good side-to-side comparison that way. So this is a little bit better to have them on their own horizontal and vertical axes like this. Okay, so this first sentence is just box plots of speed and height are shown in figure M and N respectively. So now basically all we're going to do is just describe these two figures. So let's see here. What should we say? So one thing to report as far as the values are concerned would be like a minimum and maximum. So let's say here in figure M, the minimum, maximum values of speed were, let's see, what were they? Minimum and maximum. So let's see here. For speed, the minimum was 4.5 and the maximum was 149.1. So 4.5 miles per hour and what was that? 149.1 miles per hour. 149.1. Yeah. Okay. Let's see here, the first and third quartiles were 45 and 65.3. 45 miles per hour and what did I say? 65.3? Yes. And 65.3 miles per hour. The interquartile range, QR, is, let's see here, so 65.3 minus 45.3 is 20.3 miles per hour. So I'm just kind of saying what this distance is between the first quartile and the third quartile. So far what I've done is I've said what the minimum value is, I've said what the maximum value is, I've said what the first quartile value is, what the third quartile value is, and kind of what this distance is, this interquartile range. And I've kind of said that in just 3 sentences there, 3 short sentences. Now the other thing to kind of report on with box plots is, does the data appear to be skewed? So if you remember back up here when we defined a box plot, here, if the interquartile range appears to be, closer to the maximum, this is left skewed. If this box appears to be closer to the minimum, then it's going to be right skewed. If it's not skewed, then you're going to have this box kind of centered between the minimum and the maximum. So when I look at my box plots, here's the maximum, here's the minimum. It looks like the box is closer to the minimum value here, and it's closer to the minimum value here. So that's what I'm going to say, is I'm just going to kind of describe that observation. So I'm going to say, let's see, how can I say this? Let's see, first quartile and third quartile box is not centrally located. The first quartile, third quartile box is closer to the minimum value, indicating the data, indicating the speed and the variable is right skewed. Change this to Q1 to Q3. So what I'm saying here is this Q1 to Q3 box is not in the center between the minimum and the maximum. Let me see, it's not centrally located. Let me put between the minimum and maximum values. The Q1, Q3 box is closer to the minimum value. So this box is closer to the minimum value, indicating the speed random variable is maybe slightly right skewed. Say similarly, the Q1 3 box the height random variable is not centrally located between the minimum and maximum values. And I'm pretty much going to say the same thing. The Q1 to Q3 box is closer to the minimum value, indicating the height variable is also slightly right skewed. All right. So that's basically it. So, these first 4 sentences were used to describe this one. And it looks like I didn't report the minimum and maximum values for height. So let me do that. Okay. So let's see here. I need to put, let me put in figure N, minimum, maximum values of height for 8 and 420. For 8 and 420. The first and third quartiles were 75 and 154. 75 feet and 154 feet. Enter quartile range. QR. is, let's see, the difference between those two. Do this really quick on the calculator. 154 minus 75 is 79. So the interquartile range is 79 feet. And instead of similarly, I'm going to say similar to the speed random variable. The first quartile, third quartile box for the height random variable is not centrally located, meaning it's not positioned right here between the minimum and maximum. The first and third quartile box is closer to the minimum value, indicating the height random variable is also slightly right skewed. So in the results section of a report or paper, you're basically just kind of describing this picture. You know, imagine if you're trying to talk to somebody who had their eyes closed and they couldn't see this picture. You know, what details could you tell them about the box plot that would help them to form this picture in their mind? So you're just kind of giving the details as you see it in this figure. Now, we're doing nothing more than just describing the figure. We're not talking about any of the implications or anything this means. We're not trying to interpret these yet. We'll do that in the discussion section, which will come next. But right now in results, you just put in your figures and you describe the figures, and that's all. So this is all we have to do for including the box plots for the random variable that you're interested in. All right, that concludes this guided tutorial.